Okay, the first problem we're going to look at is about finding the position of a particle from the velocity. So it's a differential equation. We're going to have to use separation of variables to solve it, and it's a velocity position type problem back from the first part of the class. So when I look at this, the first thing I do is try to figure out what I'm solving for. So we know that velocity, this is velocity, is equal to dx dt, where x is our position. And we have an equation for this, and that's 2t e to the minus tangent of x times cosine squared x. Now we're not going to use this initial condition until the very end. So for now, let's look at this. And we're going to want to use separation of variables. It's the only way we know how to solve this. So the way we do separation of variables is we want all of the x's on one side and all of the t's on the other. So I'm going to write this dx over, and I'm going to divide over all of this stuff. So it's dx over e to the minus tangent x cosine squared x is equal to, now I'm going to get this guy and I'm going to multiply it over. So the way you want this to look is you always want, so I'm going to have 2t dt, and if you're confused on which one should go where, you always want these, your dt, your differentials, they should always be in the numerator. It doesn't make sense to divide by them. So numerator. Now once we have something like this, we can go ahead and integrate it. So this one we're going to integrate with respect to x, and this one we're going to integrate with respect to t. So this tells us that if we do the integral dx, before we do that actually, let's note something. E to the minus tangent x is equal to 1 over e to the tangent x. Also, 1 over cosine squared x, or 1 over cosine x, is equal to secant x. So what I really have on the right hand side is e to the tangent x times secant squared x dx. So let's see what that looks like. Our right hand side is e to the tangent x, because we had 1 over e to the minus tangent x, and we had 1 over cosine squared, so that's secant squared x dx is equal to, and now the left hand side, and we just had 2t dt. And we're just going to do this definite integral. So for the left hand side, which is this, how do we solve this? Well, let's just use a u substitution. Because I have tangent x, the derivative of tangent x is secant squared, so that's going to work out. U is equal to tangent x du is equal to secant squared x dx. So e to the tangent x secant squared x dx is equal to e to the u du. Well, and we know that integral, that's just e to the u, where if we plug in the right stuff, e to the tangent x. That's going to be our left-hand side. Now let's look here at our right-hand side. Well, our right-hand side is going to be pretty easy, right? We just have 2 t dt, which is just going to be t squared. Now that we have left-hand side and right-hand side, we can set these two equal. Oh, there's one thing we forgot here. What did we forget? We forgot our constant. This is an indefinite integral. So you can't forget this. This is going to be very important. Okay, so let's go to the next page. We have e to the tangent x is equal to t squared plus c. And now let's use our initial condition. We could use it anywhere, but here's not a bad place, because we know that x of 0 is equal to pi over 4. Now what is this 0? This is t is equal to 0. So we just plug this in here. We get e to the tangent, well, when x is equal to 0, or when t is equal to 0, x is equal to pi over 4, so tangent pi over 4 is equal to 0 plus c. So c is equal to e to the tangent pi over 4. What is tangent pi over 4? Well, that's just 1, e to the 1. You can see this because this is pi over 4, right? And sine and cosine are going to be the same. Okay. So now we know that we can plug in for c because we know exactly what it is. E to the tangent x is equal to e plus t squared. Now we want to solve for x of t. So let's take the logarithm of both sides. We have that tangent x is equal to ln of e plus t squared, or x of t is equal to, well, that's just arctan of ln of t squared plus e. And this is going to be our solution. Now you can check this. I like to check the initial condition always. X of 0 is equal to arctan of ln of e. Well, this is arctan of 1, which is equal to pi over 4. So it checks out.